I have an interesting plan today, and that is decompiling a decompiler in Java. So let's just search for decompiler. And my goal is, not really sure what my goal is, but I would like to see what we can find out about decompilers by decompiling the decompiler. Okay, and for that, I will just download this decompiler. Let's see. And that should be it already. Okay. Then let's just duplicate the decompiler and call it that. And I should have Java installed, yes. Let's fire it. Let's fire it up. Okay, let's load the decompiler. Let's see what we can learn. Or is it open source? That would be that would be embarrassing. Let's check if it's open source. Because there's obviously no point in decompiling something that is open source, except we could compare the source code of the decompiler with the open source code. And this is a GitHub domain. So there should be a GitHub project somewhere. Ah, there it is. This one should be it. Yep. Then let's just get the code as well. Before I do anything, do I have tmux here? No. I'm just installing tmux. That is a tool that changed my life. It's a terminal multiplexer, and as you can see, I have fired it up, and we can create another terminal inside the terminal and yet another terminal here. Now we have 3 terminals that we can switch between, and we can have a look at all of them simultaneously. I usually use the left-hand terminal window for Vim and the other one for, well, managing stuff. So let's clone the repository. Why is the link not working? Okay. Maybe I should set up C tags here as well, just to be able to navigate the source code better. I recently wrote a blog post about that. And that is the command I need. Okay. CTEX needs to be installed as well. obviously. Let's try it again. And that's the generated file with the syntax for the entire project. And looks like it was a success. So now we can jump between different code files, source code files, quite quickly. But let's just have a look where we should start in here. Maybe let's just query all Java files. Okay, I see there's API files and SPI files. I don't know what SPI is. Let's have a look what that is. The API is the description of classes, interfaces, methods that you call and use to achieve a goal. The SPI is the description of classes, interface methods that you extend and implement to achieve a goal. Aha. But we also implement API classes. Well, okay, it depends on how we understand API. Okay, but I think I got it. So for me, interesting starting point would be API. It's not found. Great. File loader. File loader would also be not bad. No text file. Of course I have to load the text file before. Like this in the vimrc file. So let's open the vimrc and set the tags. And then do SO, this, no. Okay. SO percentage. So now I can go to the API class. It apparently does not exist. I think it got the path wrong because the repository is located in downloads. Probably it's better when generating C tags to provide the full path. C tags are, yeah, that's probably the problem. Let me do this. Yeah, I'm stupid. Okay, so then now the tag works. Great. Some of the terminal color is a bit odd. Can I change it? Preferences, colors. That's better already. Ooh. Yeah, that's the best for me. Okay, let's keep it like this. This is fine. Okay, so as a starting point, what we do is open a file, and we open this jar file here. So the key operation is, I would say, opening a file. Right? So we could find out what open file does. But how would we find the right place in the code? We could find this button, but I don't know if it's implemented explicitly. But there should be something here. Select location view might be a tag. Select location view. No, that's probably not it. File loader service, that sounds promising. Tag file loader service. Okay, that's a service that retrieves file loaders. And there are many possible file loaders available. What's the extension service? Let's find out which other classes start with the name file. Nothing interesting. How about something that contains the string import? Nothing. So just to be clear, I'm still finding or trying to find a starting point. The app package is very likely the user interface, I would say, because this one of the subdirectories is GUI. Okay, let's check app. Yeah, that's the user interface. And there's also an OS X app. What does this mean? It's an extension of the user interface. Create an instance of the Mac OS X application class. So for Mac, there seems to be custom class application used. But what does it do? Okay, it's called some system-specific handles. Not very helpful so far. I just want to do something with this application, understand something or whatever. Something. Services, maybe. Let's check services. Website? No. Let's check the Linux. It does not look good as well. Oh, okay, the directories are quite helpful. There's a file loader, then there's a container, source saver, an indexer, tree node, okay, generic stuff, model, and then in util there's decompiler, so that should be the heart of it, shouldn't it? So what if I do the following? Jar container entry util. What is this? I'm just looking at this class reader here. Is this a class reader that is implemented in this project, or is this something available from Java? Aha, okay, Object Web ASM class reader. Let's have a look what that is. Maybe this tool doesn't even decompile anything on its own, but just provides the interface, the user interface to do it. Okay, the class reader is a parser to make a class visitor visit a class file structure. So that sounds very interesting, because class files are the compiled.java files as defined in the Java virtual machine specification. I think the word visit is also very intentional, because the visitor pattern is a known term in backend engineering. So this is something, let's have a quick look at it. Visitor pattern. A visitor pattern is a software design pattern that separates the algorithm from the object structure. Because of this separation, new operations can be added to existing object structures without modifying the structures. Yeah. Okay, this class passes the class file content and calls the appropriate visit methods of a given class visitor. So class visitor is a class that has a visit method. And the visit method should receive something about some information about the class file, and all the logic that is executed is implemented in the visit method. Yeah, so there's a visit method and it's provided the class header, and then the visit method can do anything with it. And I guess that's an abstract class, right? So you have to implement the visit methods, I would say, yourself. Let's check for confirmation. Where can I see what is abstract and what is not? Okay, I guess it's all implemented, but probably you have to write a subclass of this and override the visit implementation. For example, this would be the case in any of these subclasses. For example, check class adapter. Let's have a look at this. A class visitor that checks that its methods are properly used. Yeah, overrides the visit class in class visitor as expected. Okay, whatever. So these are classes that can, or that read the .class files, the bytecode files, and can do something with it. This class passes the class file content and calls the appropriate visit methods of a given class visitor for each field method and bytecode instruction encountered. A visit method is called for each field method and bytecode instruction encountered. Let's have a look at the source code again. Where was the class visitor? Okay, there's an implementation of the class visitor, and it overrides the visit inner class method. Gets provided a name, outer name, inner name. Okay, and through that method it populates. I think this is a map. It is a hash set inner type paths. But what is inner type in this context? And outer type. Okay, it seems to have something to do with the naming of the class files, which resembles something like, like these class names here, but ending then with .class. I would say that .org, .objectweb, .asm are outer types, and the class name is inner type. But I might be wrong, okay? But so my understanding is that this is parsing the class names and getting them. And then the interesting thing that happens here is that a class reader what is skip code? A flag to skip the code attributes. Wow, this is really some hard stuff here. I think what this class does is it receives a jar file, which is ultimately a collection of entries. And these entries are compressed or wrapped files, class files. And it tries to extract the inner files and get some information from them. That's my understanding right now. And let's have a look at... Okay, and before we continue, my understanding is that the bytecode processing is not done here. The bytecode level processing is done using asm.ow2.io, which is an all-purpose Java bytecode manipulation and analysis framework. Interesting. It can be used to modify existing classes or to dynamically generate classes directly in binary form. So this is what provides the logic. ASM provides some common bytecode transformations and analysis algorithms. And it seems to be a relatively popular project, at least for people who care about bytecode level programming. OpenJDK does it, uses it, the Groovy compiler uses it, and the Kotlin compiler uses it. So these are quite some big projects. Let's have a look at this developer guide for a second. Can we see something interesting here? And main algorithms already states that the class reader is one of the most important classes there. And the class reader algorithm is quite straightforward. Okay, it's summarized below. It parses the constant pool in the bootstrap methods in a constructor. Okay, that's definitely JVM level stuff, bytecode stuff. I read a book, or at least the introduction to a book, a while ago. It was very interesting. It was this one, Java Performance. There was some interesting explanations to Java bytecode. You don't have to buy this. It's available for free if you look for it for a couple of minutes. And it was very interesting, but I think this information here goes beyond that even. But if you know bytecode, then apparently this class reader is straightforward. It parses the class in the accept and read methods, parses the header, class attributes, and then calls the visit methods. And you then, if you implement the class visitor, you can do whatever you want with the bytecode then. Let's have a look at Java bytecode for a second. So maybe there's some fundamental concept that we're missing, which makes everything very easy. So here's an example of Java code, and this is the translated bytecode. And I think that these are some constants. As I push 1000, you can see that's the loop variable here, or the loop upper limit. Then what else is there that we can find in the source code? It looks to me as if the iload1 is related to the variable I, but I don't know for sure because here it is defined. It says iStore1, iLoad1. Then it is referred to second time. I don't know for sure. There's a goto statement, go to line 38, which is interesting because gotos in the Java main languages are absolutely frowned upon. And line 38, I think inc, that would be probably that is the goto statement. But no, there are multiple goto statements. So it's probably the continue and then it's various jumps if the for loops exit. So yeah, that is how bytecode looks like. Aha. The prefix I stands for integer. So that's where the I here comes from. It's integer constant 2. Integer constant 2. Maybe that's how it works. For example, I_5 will push an integer with the value 5 onto the stack. Yeah. And this will push an integer with the value 2 onto the stack. What's the difference between push onto the stack and store? Stores the integer on top of the stack into local variable 1. Yeah, but push and store, there must be a difference. Anyways, that's very interesting. So this is all code that analyzes this bytecode. Let's have a look at another similar class of the decompiler, just to confirm that the decompilation is not done here, or at least not to the degree I have expected it. Let's check the string builder printer. Okay, there's not much logic in here. Also no external dependencies. How about class path loader? I think this loads a class file, or this definitely loads some file, because here it says this.get class get resource as stream, and this then refers to some name.class and creates an input stream based off that, and then tries to write. Does it write it somewhere? Output to byte array. Yeah. Yeah, okay. Yeah, it loads a file and returns the byte array based off that file. So, okay, nothing interesting going on here. This is the kind of class that if you code it once and it works, then you'll probably never have to touch it again. Line number string. Line number string builder printer. Okay, this is also just associating line numbers with the code. I'm still looking at the decompiler classes, but we have looked at all of them already. I'm not sure if really all the logic happens inside the jar container entry. Jar container entry util. No. What did I do? For example, this class that we looked at has the class reader, and it reads the loaded class files. But what does it then do with the read class files? For example, this method does not return anything. It's just a class visitor populating the inner type paths. The inner type paths then. What happens to them? Populate inner type paths. Okay. And this method returns a collection of container entries. What are containers? It's just something here I defined in this local project. Let's have just a quick look at how this method, the jar container entry util, looks like in the decompiled version. That would be interesting. Oh, there's a method class file to Java source decompile. How did I not see that? Let's check class file to I can't open it via the ctags, so it's not defined in the source code, apparently. But why is it available here? Class file, because this looks like what we need. JD core. Do we have JD core available here? Maybe we're just looking in the wrong project, in the user interface project. Where does the JD core come from? Class file to Java source decompiler. I think this is a pure user interface project, and the JD core might be a dependency. I have no idea how Gradle works, so I would have to figure out where the dependencies are declared. Let's have a look at the Java decompiler user on GitHub, and there it is, JD core. That's it. So all the time we were just trying to decompile or figure out the user interface. But what the user interface does is it does read parts of the jar file it appears, but it only does it to be able to list the class file entries. So that's why we have these class file related loaders here: class path loader, jar container entry, container loader. But we don't have any actual decompilation logic here. So this is something I should have known from the beginning, but you're always a bit wiser after in hindsight. And yeah, checking the JD core might be something we can do next time. But for today, I would say a lot of interesting stuff that we have looked at. Let's just have a quick comparison of the jar container entry util before we close this off, because that's what would be interesting. It's located in org JD GUI util container. I was really wondering about the lack of logic in this project, but okay, it's obvious if this is just a user interface project. So let's have a look. Interestingly, what I find really interesting is that the decompiled source code looks very clear text. Maybe it is the case that this is compiled with sources. So, you can compile, as far as I know, you can compile Java files and put the sources into the files as well. But I don't know. Let's check this class visitor. Here it says class visitor. Class visitor is equal to new class visitor. And then there's an arbitrary number. Let's see if that number appears here as well. That's the opcodes, ASM7 enumeration. So that's an enum, and in the bytecode the enum is lost, There's also no dependency on that opcode package. There is likely one here, opcodes, but in the bytecode this was optimized away, so it's not visible here. But aside from that, the source is very clear, and the variable names are all identical. So this is interesting. I wonder if this is related to the jar file directly. So I would like to see the jar file of that. So let's just have a look at the jar directly. So I have opened it in Vim right now. You can see there's a lot of class files here. And let's search for the one we're looking at, jar container entry util. Jar container entry util. And that's this one. Why does this one have $1? That's probably something, that's likely something I saw here that is related. There are paths that contain a $. Let's have a look at why that is. Jar $path class. It might be because I have this specific file open in an editor, so there's no special reason for it. Because this class file is also available twice here. So let's see what happens if I close it and then reload this file. Oh, there are many tree viewers here. I don't know. Let's repeat the search. Yeah, doesn't matter. And as you can see in the class file, there's a lot of clear text available. Yeah, we can see the ASM class reader here. We can see all the classes defined. I think the variable names are obfuscated, or at least stored in some binary format here that we can't see. But aside from that, it's relatively clear text. I find interesting that we don't see any variable or method names. It's just dependencies that are available as clear text here, or external classes. And of course calls to those classes as well. But our own custom defined methods, they are not available there. Okay, so let's close this video for now. I think we have learned enough about bytecode decompilation, or about this specific project. It's a UI project that makes use of the JD core library and the ASM library here. And aside from that, it's just a decompiler user interface. And if you want to go code only, then this is the library that you are looking for. I don't know if you can call it via a command line. Probably not. Probably it's just a package that you can code against. But yeah, it was an interesting journey. And that's enough for today, I would say. See you next time.